So by popular demand, we're gonna make a video about every single kind of loop in Java. For that, we're gonna start by creating a new project. It's gonna be an empty project since we literally don't need except the core Java. Let's call this loops demo, for example. Save it wherever and press create. Now this project is gonna be created here. I'll make it just a bit bigger. And yeah, I'm just waiting for IntelliJ to do its magic if it has any magic to do. Then we go to project structure. I'm just gonna make sure that, yeah, like if you're like me and don't have SDK chosen, just choose one. If you have any downloaded, if not, you can always download one. Let's just, I'll just show you how to download one. I mean, you either select one here and then you're good to go, just press OK. Or if you want to download a new one, go to here, press download. Let's say I want a new JDK, choose one of them. It doesn't matter which one of the companies you grab here. It's just a bunch of different companies that all offer their own implementations of Java. For this level, they're all going to work exactly the same. There's like microscopic differences, but that's on such a technical level that for this tutorial, it makes absolutely no difference. Yep, and that's it. You just press download and you press apply and OK. It's also important this has to be on the same level as you've chosen here or lower. Like don't choose something higher. For example, if I choose, I mean, I don't have it, but sometimes you can have here 22. Like if you choose 21, but you only chosen Java 17, it's not gonna work properly. So now that we started, just create here some kind of a Java class. Let's call this loop runner or whatever. And we're gonna do everything in the same class, and off we go. So let's just make sure first of all that everything is working. Um, Here we go to demo or something. I just want to see that it works, that everything was set up correctly. And yeah, we can indeed print it out and everything works good. Now we can start looping. Awesome. Let's start with understanding what is a loop. So basically, loop is a construct that allows us to do something repeatedly, right? Because let's say you want to print out something simple like hello there. And let's say you want to print it out 5 times. Now you could do it like, duplicate this line 5 times, but maybe it's 25, maybe it's 100 times. That's going to be extremely inefficient to keep duplicating, your code. Or you can have a construct. Uh, I'm going to write it out. So zeros until 5, for example. And I say plus plus, and I move this here. And now I can print this, and it will indeed work exactly 5 times, as you can see here, right? So loop allows us to define very simply some kind of it's a construct that says where we declare a variable. Usually we declare it. I mean, I could have, declared in advance here, then it would have worked just as fine. Then I provide this, the middle part is probably the most important, or maybe the only important one, because, theoretically we can get rid of these. And the middle one is basically has to be a condition. If provided, it has to be a condition. As long as it's true, it returns true, the loop will keep running. So this will be true 10 times, after which I will be higher than 10 and it will not run anymore, right? But if we could just, return true here, like any Boolean condition can be put in the middle. And as long as it's true, the simple for loop will keep running. Now it's an infinite loop. It will keep running until, forever probably. So we can just stop it, or we can do something else, like we can do pretty much anything. This, for example, is false, always false. Yeah, now it's unreachable code, that doesn't help us. But we could do something that's, less easy for Java to deduce. And now it's, even though it's always true, yeah, let's do something that's always false. It's always false now. Okay, yeah, but it's unreachable. So you can't put false, but I can do something like this. 1 equals 1. Does this go? No, it just sees it. Yeah, here we go. So I equals 1. That will immediately be false, and this will never run. That's fine. So we can just put any Boolean condition here. It's also possible, just so you know, all the options, to not put anything in a for loop. That is not very usual, but just so you know, this is a legal construct, and this is just another form of infinite loop. Because if there is no Boolean conditions, there is no Boolean conditions that will return false, and the loop will keep running forever. But yeah, but let's return to our usual, constellation, which is we define here as I. We add, we provide a condition, which is like I want it to run as long as I is under 4. And then we do some condition like how we want to update the I. Now, while this is the most usual form, you can and you should, by the way, to really learn loops, you should play with it, like really play with it, and understand that you can do anything you want here. As long as the middle part returns a Boolean, you can do whatever you want. For example, here, let's say I put another count variable count, and I'm just gonna throw it here and say, and also please increment my count. Not that I need it for whatever reason, but it's absolutely not a problem for me to do. Count equals count. And you can see that, I just created another variable that also incremented as many times as the loop run. So yeah, that's also possible. I can do it as many times as I want. I mean, I can do something stupid and do this. Makes no sense. Count's gonna stay 0. Um, but I just want you to know that you just have the possibilities, like as long as the loop always has 3 parts, the traditional for loop, they're separated by semicolons. So 2 semicolons separates 3 parts. Let me just throw them like this so you see them very clearly. These are my 3 parts, right? Java doesn't care about spaces, so I'm allowed to do this. So this is my part 1, uh, initialization. Initialization part. Let me just copy this. Part 2 returns false Boolean, and whenever false loop doesn't run anymore. Part 3 update part, usually of counter variables, right? And again, all parts are optional. Every single part of this is optional. Like you can remove this part. Let's just comment it out so we don't have to remove it. And this still will work. I mean, it's a stupid loop, like it will run forever because I will never increment, so it will always be true. But we can do it. That works. I'll just drop it. I can remove this. And then as long as it still compiles, this is legal, right? So it's always what count less than 4 is not a statement. Why not? Oh yeah, I forgot this. So while I'm allowed to comment everything out, I still need my semicolons. Yeah, it also works. Also forever true. Not a problem. And I can remove this as well. Again, I'll comment it out maybe. And again, you can comment everything out, but semicolons have to stay, right? So essentially what I'm doing right now is the same as, let me just put it for you in the same line as this. And again, this is an unreachable statement, Java just complaining. But basically, this is legal. Yeah, I'm just coming back to the same part. That's not the point I'm trying to make. The point I'm trying to explain to you is that traditional for loops, this is important, consists of 3 parts. And while all the parts are optional, and also in all of the parts you can do as many stuff as you want. You can initialize another variable called p, another one called c. This is all absolutely fine. You can create 1 million variables. That's fine. It's not a problem. You don't have to use them. You can use them. This is all very, very normal. So now that you know this, so that you know you can play with these loops as much as you want, and I do encourage you to play with them because if you play with them, you really get them. What you probably what you really want to know is what's the most common way of using them. Well, pretty much when we very usual use case is to traverse an array. So let's say we have an array. Let's call it by an original name of array. Let's initialize it with a short initialization form. And these are my options. Maybe let's change up some variables here. Yeah. So now I want to go through it. So I say run as long as the index is lower than length, because as you probably know, array has indexes for us to be able to um access elements, and the first element is accessed with an index of 0, which coincidentally would took us the first value. Then the second one will be one like index 1, index 2, index 3, and index 4. And the array's length is obviously uh, array's length is 5. But the last index is 4, which is why we say run until you hit the length, but don't run like run while you're shorter than like smaller than length. As soon as it hits the length, we stop, which is just extremely usual. So you can see that the array length is 5 exactly. The last index is 4. And that's exactly how we use it. So we just say, for example, we want to print every single element of an array. We just say, not that array, yeah, this array. And we just say, please print every single element in that array one by one. There you go. Maybe we want, let's do print, the one that doesn't have any new line. And then I say space and then minus and then at the end, yeah, let's just do that. And then let's print them like this. And you can see we're getting this. Now we see that we might want actually another space here. And now it's nice. But we see that at the end, the minus is a bit awkward. So let's just do something, a bit of programming, because we're smart programmers and we know how to do it. If I equals to array.length minus 1, so we're at the last one, then s out. So we don't want this basically. We want it for every single one of them except the last one. Like we want to put this in the middle of all after each of them, but not after the last one. And now it's perfectly beautiful. Yeah, so that's our very simple use case for an array. Now you might be thinking, cool, that's a traditional for array, but there are other forms of arrays like while. Now, how does while look work? Well, pretty much the same. Um, but we focus exactly on the middle. So, remember I told you that, for loop has three parts, and the important part is the middle part because this one decides whether the loop runs. Well, and before that you have the initialization part, you have the update part. Well, while loop pretty much gets rid of this part, it gets rid of this part, and all it looks at is the Boolean condition. Then while that Boolean condition is true, it will keep running. So we can pretty much do the same thing. We say whatever our initialization is, let's use some other variable, counter. And I say while counter is less than array.length, keep printing current element of an array. Oh yeah, counter. And right after that, let's just, increment the value. And I'll put a nice separation here so you guys see that, oops, when it separates. So you see here we printed this. Oh yeah, I forgot to add a new line after. So yeah, first we printed this. This was this loop. Then we make a separation here. And now we move to the while loop. Maybe I should announce it so that it's a bit while loop. That's my while loop. That's my um, traditional for loop. And now you guys can see it a bit better. So this is my traditional for loop. This is my while loop. And you see, it works pretty much the same thing. We can do exactly the same thing, by the way, not a problem. again, something like this. And again, it will do the same. This time I didn't add the whole if logic for the last index, but I could have. And you can see that you can do exactly the same thing in a while loop. The only difference is that for loop has sometimes, seen as useful uh, kind of initialization part, update part, and for loop obviously works with indexes. I mean, theoretically you don't have to, but practically that's what for loop is. You're literally showing going for an index. While loop often doesn't have to go for an index. You often do some other conditions, but while that condition is true, this loop runs. Now, there's also a do while loop, which is honestly extremely similar. So do it's written like this. So do something while this goes here, and this is the only loop that requires a semicolon at the end. Like without it, it will be right. And now let's put some other variable int index this time, right? And I'm just going to use index just so we're nice and clear. And this will be our do while loop. Now you can see that our do while loop, I am doing something wrong. I'm saying use an index while, oh yeah, I'm still using counter. Yeah, that was just me. So you can see that these loops work exactly the same way in this example. So you might be thinking, well, is there some big difference between while and do while? Yes, there is. There's one very specific difference, namely, do while loop always runs at least once, even if the condition is wrong. Now, in this case, condition is true, so you don't notice it. But if the condition is wrong from the get-go, like in both cases, we do counter 100, which is bigger than the array length, so it will not run. You will see that while loop will not run even once. For loop will also not run even once. And do while loop is the only one that will still run once. Oh yeah, we got some, yeah, it ran once, then it tried to access it and got index out of bounds exception. Let's avoid exceptions if index less than array.length. So if it's a legal index, only then do something with it. So I'm just avoiding the exception. But you can see that the do while, or let's print something then. As out in do while. So you guys actually can see it in while and in for loop. So you will see that only the in do while ran. In for loop didn't run because the condition is wrong. The while loop didn't run because the condition is wrong. And the whole point of do while is that it runs at least once. Now you might be thinking, what the hell? Why do we even care about some stupid loops that runs always once? That's kind of confusing. So let me show you an example where that kind of makes sense, or a common example, at least in universities. For example, let's say we have a do while loop. Some condition, I'll get to it. And let's say we want to write a program that generates random joke. I don't know, get random joke. String joke equals get random joke. And we'll print our joke. I'll create this method for us. And I don't know, return. Let's create here some new string. Pa-pa-pam. String jokes. Return jokes dot int random index equals new random next int within a bound of jokes length. You don't have to understand all of this, this is just, you can just focus on the loop. I'm just coming up with some logic for fun. And let's say, I don't know, some jokes, right? I don't know. What jokes do we know? Why did the programmer code in Java? Because he couldn't C sharp. I don't know what else. Uh, why did father teach his kids single quotes? Because they build character. And I don't know, some third one. Why programmers take so long in the shower? Because instructions, rinse and repeat, send them into recursive loop. So there's our method. It just, it goes through these jokes. If I create it correctly, with a bound, is a bound inclusive or exclusive? Exclusive, perfect. So it will generate us some bound between 0 and this length, and it will randomly return it. And let's say we want to print this. Without enter a for another or x to exit. So we always want to do this once, and then we want to listen to user feedback. So we use string user input equals a new scanner system.in dot next line dot trim. I'll throw this into variable, so maybe it's a bit easier to understand. Don't have to create it in a loop. And then I say while user input doesn't equals to x, right? And let's just do it like this. So, and yeah. So while user input doesn't equal to x, it will keep repeating it. But I always want it to run once, right? So I know that's kind of the logic. Of course, you could have also done it with while loop, but that's the idea of this will always run once. Doesn't matter. Even if we put it as x to begin with, it will still run at least once, and then it will get overwritten, right? So we run it, and it says this is a joke. Why did the Java programmer write code in Java? And then it asks, hey, do you want another one? Yeah, I want another one. I want another one, and now I want to exit. And that was it. So that's our little cool program, and that's why we want the while loop. So now you might have noticed I went through the traditional for loop, I went through the while loop, and now I explained the while loop. There's one more loop that I didn't touch yet, and that's enhanced for loop. And I would like to touch on that one again also. So going back to our traditional loop, right? Let's create some string array for us. Equals new string. Let's write it like this. And this is apple, orange, pear. And I say array.length, and I say print out every single element, please. Right? And this works easy breezy. As you noticed, I'm not really using indexes here. All I want to do is do something with every element one by one. So I don't need any special logic for indexes. I just want to print them each one by one out. And that's why there's an enhanced for loop where you write the data type that's inside of an array, current element or whatever we want to call the variable. Then you put a double, like a colon, and then you write the array name because Java doesn't know which array you're talking about until you say it. And then you can just do a out array. And now that we've exactly, now we can just, like, oh yeah, what am I doing? We want to print the current element. Now if we run this, you will see that it will go twice and both loops do exactly the same thing. Just showing it to you. So the full, yeah, you see, so this is our for loop, then this is our separation line, and then this is our enhanced for loop. So this is known as enhanced for loop, and the whole point of enhanced for loop is to provide comfortable alternative to the to the normal traditional for loop. And because if you don't really care about indexes, then why do we go through the trouble of declaring variables that we're basically not really using for any other reasons and accessing every single element? There's a more comfortable solution. And there you have it. That's all the for loops you need to know about. Uh, so just to recap, we have our favorite traditional for loop. We have our enhanced for loop, which basically does exactly the same thing. Then we have our while loop. Let's just grab this and I'll just show you. And as you remember, while loop can get everything the same. You just write here while and whatever whatever logic you want for update, you would have to do it here. And last but not least, we have our do while loop. Just throw this here. This also here. The only loop that requires a semicolon at the end. And let's add an our own index. This is the index we're looking for. Exactly. So we can see that all of these loops do exactly the same thing. Like it's possible to write every single loop in the same way. The only loops that has somewhat of a limitation is enhanced for loop. Enhanced for loop can only go in one direction, which is from the first element to the last element, as opposed to all those other loops that you can go in any way and tempo that you like. You can't really uh, skip elements because you don't know indexes here. Exactly, because with every single other loop, I can add indexes if I want to. I guess I mean here I could also add an index with our custom counter variable, but generally this enhanced for loop is just for iterating every single element without skipping. If you need indexes, you go for loop. If you care about the condition and you don't really care about indexes or you just want to loop based on condition, you usually go for while loop. And honestly, we don't really use the while loops pretty much never. It's a thing from the past, back some time ago. Some people thought it was very useful, and yeah, from experience, I can just tell you that yeah, like I don't think I ever used it in real code in my work. Like I've used it in universities because they wanted to see the while loop at least once, but you pretty much don't really ever need to use a do while loop. But, doesn't hurt to know it. It's not complicated. That's it. Hope you learned something. See you next time.